The previous video, I accidentally skipped over these problems 10 through 14, so let's look at these here. The function f has property that f prime, or f of x, f prime, and f double prime, they all have negative values. Which of the following could be the graph of f? So let's think about what that statement tells us. F of x is negative. That means that our function is below the x-axis, that all of our graph has to be below the x-axis. So we can instantly take out e, right? E, we see that's not the case, so this has to be out. What f prime negative means is that our graph should always be displaying a negative slope. So we can take a out, we can take c out because we don't see a negative slope all the way through. And then the final statement, f double prime is negative, means that our graph has to always constantly show concave down. So this is out because even though this is decreasing and it's below the x-axis, we see that this portion is concave down, but then it switches to concave up. You see that? That's a concave up there. So the answer choice is going to be B. B fulfills all those conditions. It's all the graph is below the x-axis. The entire graph displays negative slope, and the entire graph displays concave down. Number 11, using substitution. U equals 2x plus 1. Evaluate or find an equivalent evaluation of the definite interval from 0 to 2, square root of 2x plus 1. Now, if we look, all these answer choices are in terms of u. So that's an indication that we're going to go through use substitution to make it match one of these forms. But one thing we have to be careful about is notice that all these terms also have bounds. And something that is not as apparent is that these bounds are also in terms of u. That's important to note. This will not be a correct statement if this is in terms of u and that's in terms of x. So that's a little bit of a hidden step that we have to be aware of after we go through use substitution. So we let the u value be what's inside the radical. Let the u value be 2x plus 1. We find du dx, which is 2. Cross multiply, we solve for dx. We get dx equals du over 2. We replace our parentheses, our radical with square root u. And then dx gets replaced with du over 2. So we push the 1/2 in front, and we have integral 1/2 u to the 1/2 du. Now we got to figure out the bounds. We can't say 0 and 2 because 0 and 2 are not in terms of u, but our integrand is in terms of u. So we have to convert our bounds in terms of u. So we're going to push 0 and 2 through this assigned expression that relates to two variables. If I plug 0 in for x, I'm going to get u is equal to 2 times 0 plus 1, which is u. So our new lower bound is 1. Our old upper bound was 2, but if I push this 2 through this expression here, I get 2 times 2 plus 1, which is 5. So our new lower bound is 1, and our new upper bound is 5. So we replace 0 and 2 with 1 and 5, and that matches answer choice C. All right, for number 12, we have to convert these statements into an equation. So let's read this word by word here. The rate of change of the volume V, rate of change, so that has to be a derivative. So we say dv dt because this is with respect to time. So we say dv dt, the rate of change of the volume V, is indirectly proportional, so that means it's going to take on the form of, is directly proportional, which is going to take on the form of y is equal to kx. So we know the rate of change of v, so the dv dt is going to be in this position, equals k times, now we got to figure out what to put in this x position here, to the square root of the volume of v. So the square root of volume of, square root of the volume. So that's square root of v. So square root of v will take the place of the x, and then we have dv dt equals k square root of v. Okay, number 13. The graph of the function is shown. at which of the following is the graph continuous but not differentiable? So continuous means no breaks in the graph, so no holes, no jumps, but not differentiable means that it's not part of a smooth curve. There's a sharp turn. So the only point that fulfills both those conditions is this point at when x is equal to a.